Okay, so we've got this power series, and we want to do the following things. We want to figure out the coefficients, the center, the radius of convergence, the endpoints, possibly, and then that's going to, if we put the radius of convergence and the endpoints together, that'll give us the interval of convergence. Okay, so first I want to in order to get a little bit of idea of what we're working with here, I'm just going to write out a few of the terms of this power series. So when n equals 0, I've got, let's see here, so for n equals 0, I'll have negative 1 to the 0, x plus 1 to the 0 over 2 to the 0. And that's just going to be 1, because everything is going to be 1, right? 1, 1. So we'll just have 1. And now what about if n equals 1? N equals 1, then we'll have negative 1 to the 1 times x plus 1 to the 1 times 2 to the 1. So we'll have negative, so that'll be negative, and it'll be x plus 1 over 2. So I'm going to say minus x plus 1 over 2. And what about when n equals 2? I guess I shouldn't have crossed those out. So let's see, if n equals 2, we'll have negative 1 squared, x plus 1 squared, 2 squared. So that'll be over 4, 1/4, and then x plus 1 squared. So it'll be plus 1/4 x plus 1 squared. And if n equals 3, then this will turn to negative 1 cubed, so it'll be minus, I can already see that. And it'll be x plus 1 cubed over 2 cubed. So 2 cubed will be 8. So I kind of get an idea of what I've got. I've got 1 minus, so let's just see what we're doing here. So I've got 1 and then minus 1/2 x plus 1 plus 1/4 x plus 1 squared minus x plus 1 cubed over 8 plus ... Okay, so my coefficients are going to be 1 negative 1/2 plus 1/4 negative 1/8 plus 1/16 negative 1 over 32 plus minus ... So for my coefficients, I can write a formula. A sub n is going to be negative 1 to the n over 2 to the n. And another way I can see that coefficient easily is by rewriting my power series. So if I take this power series and I write it as the sum from 0 to infinity, negative 1/2 to the n, x plus 1 to the n. So all I did essentially was take this x plus 1 to the n, pull it to the outside, and then combined this coefficient. So my coefficient is, this is my coefficient, is right here. Okay, so we can write this as negative 1/2 to the n. And those are my terms. My center, I can see my center just by looking at the power series. The center is going to be negative 1 because this is x plus 1. So remember the general formula. So the general formula for power series.
My web search turns something up for this is x plus 1 to remember the general formula.
Sorry. Okay, that was Siri. Okay, so a sub n and then x minus your center to the nth power. So my a sub n is negative 1/2 to the n, right? And now for my x minus c is x plus 1. So if x minus c is x plus 1, what is c? Well, c has to be negative 1, right? This is x minus negative 1. So C is negative 1. So my center is negative 1. Now, the issue is, what is my radius of convergence? And to find my radius of convergence, the key is to use the ratio test or the root test. Now, how are we going to do that? Remember, the ultimate goal, basically what we're trying to figure out, is when does the power series converge, right? For which values of x does the power series converge? So if I apply the root test to this entire power series, because look, I can rewrite this power series actually as, I can rewrite it as negative 1 times x plus 1 divided by 2, and all of that to the nth power. Okay, so I can ask myself, when does this series converge? And to do that, let's just do the root test. So for the root test, I'm going to look at L, which is equal to, the limit as n goes to infinity, of the nth root of the absolute value of what's on the inside. So negative 1 times x plus 1 over 2, absolute value. All of that to the nth power. Right, the nth root of this fraction to the nth power, that's going to cancel out, right? Because this is the limit as n goes to infinity, negative 1 times x plus 1 over 2, all of that to the nth power to the 1 over n. So the n and the 1 over n as exponents will cancel each other out, and we'll just have the limit as n goes to infinity, negative 1 x plus 1 over 2, this absolute value. So now what is this limit as n goes to infinity? This is just going to be the absolute value of negative 1 times x plus 1 over 2, because this expression has nothing to do with n, right? So we can actually pull it out to the front, and we're just left with a coefficient of 1, and the limit as n goes to infinity of 1 is just 1. But we've got that our limit, so L is equal to this value, right? So in other words, L is equal to the absolute value of x plus 1 over 2. Now, when does our series converge? So our series, which is negative 1 to the n, x plus 1 to the n, all over 2 to the n, converges. So it converges if L is less than 1. It diverges if L is greater than 1. And it is no conclusion if L equals 1. So looking at this, when is the absolute value of L less than 1? So let's actually add a page below. Add a page below. Okay, and now let me copy this. So we've got L, and we're saying that we know when our series converges. Our series converges if L is less than 1. But to say that L is less than 1, that's the same thing as saying if the absolute value of x plus 1 over 2 is less than 1, because L equals the absolute value of x plus 1 over 2. So if the absolute value of x plus 1 over 2 is less than 1. And it diverges if the absolute value of x plus 1 over 2 is greater than 1. And it's no conclusion if the absolute value of x plus 1 over 2 is equal to 1. So now let's look at when is the absolute value of x plus 1 over 2 less than 1? When is it greater than 1? And when is it equal to 1? Okay. Well, at this point, we're just solving inequalities. So the answer is to say, well, the absolute value of x plus 1 over 2 is less than 1 when, exactly when, absolute value of x plus 1 is less than 2, because I can just multiply both sides by 2, right? Both sides of the inequality. Now remember, you only have to flip the sign of the inequality if you are multiplying or dividing by a negative number. Since we're just multiplying by positive 2, we can just, we're not, we don't need to change the sign of our inequality. Now, what is this set? So for which x is the absolute value of x plus 1 less than 2? In order to easily understand this, think about what does the absolute value of x plus 1 mean? And here's what the absolute value of x plus 1 means. It means the distance between x and negative 1. Okay, so if you remember way back from your algebra, when you first learned algebra, you were a little bitty baby. Or, who knows, maybe it was last week, whenever you learned it. Remember that a minus b is the distance between a and b, right? On a number line, right? So if we have the absolute value of x plus 1, that's going to be the distance between x and negative 1, because we can rewrite this as x minus negative 1. So what does it mean to say that the distance between x and 1 is less than 2? Well, now here's negative 1, and we want the distance between x and 1 to be less than 2. So that means that x can be up to 2 units away. Do you see that? So if we go 2 units to the right, that'd be 1, and 2 units to the left, negative 3. So that means that x needs to be somewhere.
It's 12 hours.
Thank you. In between negative 3 and 1. So when is the absolute value of x plus 1 less than 2? That's the question. The answer is when x is anywhere in between negative 3 and 1. So our series converges when the absolute value of x plus 1 is less than 2. So it converges then. It diverges when the absolute value of x plus 1 is greater than 2. And we have no conclusion, so we'll put no conclusion when the absolute value of x plus 1 is equal to 2. And in terms of the number line, what that tells us is our center is at negative 1. And when the distance between x and negative 1 is less than 2, so I'm going to go out 2 units, right? So I go to 1 and then out 2 units this way. So I'm at negative 3. Sorry. So if x is in here, and by here I mean in here, in this interval here, we'll have converge, 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 converge. If x is outside of this, is more than 2 units away from negative 1, because that's what this means, right? The distance between x and negative 1 is greater than 2. So x is more than 2 units away from negative 1. Diverge, 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 diverge. And then when x is exactly 2, x is exactly 2 units away from negative 1. We've only got 2 options. That's going to be if x is exactly equal to 1, or if x is exactly equal to -3. And what we can say is, no conclusion. We don't know. So we've got our center, which is at -1. We know our radius of convergence is 2, right? So r is equal to 2 because the distance here is 2, and the distance between the center and this endpoint is 2. Our endpoints are -3 and 1. At this, the last thing we need to do, right, so we figured out r is equal to 2, and the endpoints are -3 and 1. So to determine the interval of convergence, remember we've only got 4 options, right? So we don't know if we should have converge, or if we should have converge, diverge, or if we should have diverge, or if we should have diverge, converge, right? We've got 4 different options for our interval of convergence, and now we just need to test the endpoints. So let me add a page below. So let's test the endpoints to determine if they are in our domain. Okay. So what are our endpoints? Our endpoints are -3. What does it mean to test the endpoint of -3? So I'm going to put in here at x equals -3. Let's see if our series converges or if it diverges. So now what do we have? Copy and paste. So what is this series going to equal? So if x equals -3, this series is going to be equal to 0 to infinity, -1 to the n. Now x is equal to -3, so it'll be -3 plus 1 to the n divided by 2 to the n. Okay, and what will we have? This is going to be equal to the sum from 0 to infinity. Now -3 plus 1, that's going to be -2. So we'll have -2 to the n, -1 to the n, divided by 2 to the n. And we can cancel some things out here because the -2. So this -2 to the n and -1 to the n can be combined to be 2 to the n, right? Because we've got the same base. So we can have -1 times -2 to the nth power, okay? And so then we've got 2 to the n. So 2 to the n in the numerator, and our denominator is still 2 to the n. So we're just going to have 1. All right. So this series is the series from 0 to infinity of 1. Does this series converge or diverge? It diverges by the nth term divergence test. Okay, so we've tested one endpoint and we know that at -3 our series diverges. Aha. So the series diverges. So it is not going to be included. Now we've just got to see about the other endpoint. So the other endpoint is 1. So we've got to see what's going on at x equals 1. So let's see. So at x equals 1, our series, so 0 to infinity, is going to be equal to the sum from 0 to infinity, -1 to the n, 1 plus 1 to the n, over 2 to the n. So this is going to be the sum from 0 to infinity, -1 to the n, 2 to the n over 2 to the n, and the 2 to the n's cancel out, so we just get that this series is equal to the sum from 0 to infinity of just -1 to the n. And does this converge or diverge? It diverges by the nth term divergence test. Right? Because the terms don't go to 0. They just oscillate between -1, -1, -1, and 1, -1, -1, -1, right? They're not getting closer to 0. The terms aren't getting closer to 0, so the series diverges by the nth term divergence test. So it turns out that we've got a diverge here as well. So our interval of convergence is just going to be -3 to 1 exclusive. So we're not going to include -3 and 1. Okay. Now, you might be saying to yourself, man, that took a long time. And it sure did. That's why I want to show you a quicker way. Sometimes when you have a very special series, so sometimes when you have a very special series, you can speed up this process by recognizing that the series that we have is actually a geometric power series. And so what do I mean by that? Here's what I mean. This series, remember how we said that we could rewrite it as from 0 to infinity, -1 times x plus 1 to the n, all over 2, all of this to the n. So this is a geometric series. And we know that geometric series, so we know that if you have r to the n, it's going to converge only, so it converges if r is in between 1 and -1, and it diverges if r is bigger than or equal to 1, or r is less than or equal to -1, right? So we could say that our series, and what do we have? -1 times x plus 1 over 2 to the n is going to converge if this inside part here, because this is r, right? So converges if -1 x plus 1 over 2 is in between 1 and -1. And so now we could unwrap this, solve this inequality. So we'll multiply both sides by 2, right? So we'll have 2 less than -1 x plus 1, -2. And then we can multiply on the inside. We'll have -x minus 1 less than 2 less than -2. If I add 1, then I'll have 3 -x -1. And now this splits up into -1 is less than -x and -x is less than 3. Okay, so over here I can just add x to both sides. Right, so I'd have x minus 1 less than 0. Add 1 to both sides, x is less than 1. And over here, add x to both sides. I have x plus 3 greater than 0. Subtract 3 from both sides. I'll have x bigger than -3. So my requirement is that x is less than 1 and x is greater than -3, which gives us -3, 1, that this is our domain, from -3 to 1. And then we could find the center by finding the midpoint. And so the center would be equal to the midpoint of the interval. And what is the midpoint? Well, we could say 1 minus -3 over 2 is going to be, what is that, 4 over 2, which is 2. So this is going to be the radius. So we need this plus an endpoint, right? So in other words, this whole distance is 4. So half of this distance is 2. And so what number is in the center? -3 plus 2, which would be -1. That makes sense. Okay, so center is the midpoint of the interval, and the radius of convergence is half of the length of the interval. Half of the length of the interval. Okay, and in fact, we know, we can take it a little bit further and say that we know that if it converges, so here, if you have this series, it converges to, what does it converge to? What is the sum? It converges to 1 over 1 minus r, right? So this series is going to be equal to 1 over 1 minus all of this pink stuff. So -1 x plus 1 over 2, which is equal to, multiply the top and bottom by 2, 2 over 2 minus v2 plus x plus 1, which would be 2 over x plus 3. So the function 2 over x plus 3 is represented by this power series. Okay, so x plus, so if we look at f of x, which is equal to 2 over x plus 3, this is a rational function, right? We know it has an asymptote at -3. Guess why it has an asymptote at -3? For the reason why it has an asymptote at -3 is exactly why the radius of convergence only goes out to 2. Because if you're at -1 and you try to extend the domain past 2, right, past -3, you're trying to cross over an asymptote over here, right? So we'll get into representing.
It's 12:15.
Thank you. We'll get into representing power series a little bit. We'll get into that a little bit more. But for now, the takeaway messages are: number 1, when you're trying to find your radius and your interval of convergence and your endpoints, for your radius, you're going to use the ratio test or the root test. In this situation, we use the root test. Okay. From there, you're going to be able, from the root test, you're going to get you should be able to figure out your radius and your endpoints, right? So we did the root test, and from the root test, we were able to use when the series converges, that gives us our radius of convergence. And then when there's no conclusion, this gives us the endpoints, right? And so when you're able to get it of this form, x plus c less than 2, that 2 right there is your radius of convergence. Okay? And then to find your interval of convergence, you're going to have to test your endpoints. So once you know your endpoints, and in this case we had endpoints at -3 and 1, we had to plug in the endpoints and then test the series to see if it converges or diverges at the endpoint. And then use that to determine our interval of convergence. And then the fourth piece of information to remember is that if we can recognize that a series looks like something that we know how to work with, like for instance a geometric series, then it's a real shortcut for us because we can borrow the information that we have, borrow the information that we know about a geometric series, for instance, and then use that to give us information about this power series, right? So we can piggyback off of the knowledge that we have of geometric series in general to give us information about the interval of convergence and the radius of convergence for a geometric power series. All right, that's it.